All right, let's talk about how are we going to approach these stoichiometric problems. And the ones that we're going to work on today are mole to mole conversion. Oops, that should be a B. And what we're going to do is I'm going to work the sample problem on this side, and I'm going to list the steps over here. The first thing that we're going to need, so step number 1, is to write and balance an equation. Sometimes the equation will be provided for you, but sometimes you'll have to write the equation from the word problem. We're going to talk a little bit about how do we figure this out. All right, the elements, lithium and oxygen, react explosively to form lithium oxide, Li2O. How many moles of lithium oxide will form if 2 moles of lithium react? So this second sentence is what our question, what we're trying to solve for. The first sentence tells us what happens here. And you'll notice here it says the elements, and it has lithium and oxygen. And that tells me that I have elemental lithium, which is Li, so that's going to be a solid, reacting with elemental oxygen, O2, which is a gas. And it tells me that lithium oxide, lithium's +1 when it forms an ionic compound, oxide becomes -2. So my formula here is Li2O, but I need to balance. So, and I'm going to put these, pick a different color. I've got 2 lithium on this side, so I want 2 here. Whoops, I did that back. I should have done, grab my white out. I've got 2 oxygen over here, so I need 2 oxygen there. That means I'm going to need 4 lithium. And there's a 1 here. So when I get into this and I talk about mole ratios, I'm going to talk about 4 moles of lithium reacting with 1 mole of oxygen and vice versa. Once you have that equation, the next thing that you want to do is to frame up the problem. This should seem familiar because back when we did dimensional analysis, this is what I told you to do. The question word, so you look for that question word, and that's what we're solving for. And what's given is what we're starting with. The given value is our starting point. So, how many moles of lithium? That tells me that I am solving for moles of lithium. I'm going to put that on the other side of the equal sign. And the problem is telling me that I have how many moles? Oh, I should have kept reading. Lithium oxide will form if 2 moles of lithium react. So I'm starting with 2 moles of lithium, and remember we always put that over 1 to get that into fraction form. Now here's something different that we're going to do. What I want you to do is I want you to write in green, well, for me, I'm going to do it in green. I'm going to write A over what I'm starting with, and I'm going to write B in what I'm going to. Now remember our diagram. I'm going to rewrite that diagram. I'm going to encourage you to write this diagram at the top of every page where I have the mass of A. And that's going to take me to moles of A. And we're talking about whatever compound A is. And then I can use the mole ratio to go to moles of B. And I can get between mass of B. And remember the conversion factor that gets us between Mole and mass is molar mass. Molar mass of B, and this is going to be the molar mass of A. And I'm going to encourage you to use this diagram as much as possible. So when I framed up my problem, I looked at what I was starting with and what I was going to, and I kind of got ahead of myself because step three is to label your start and stop. Label compound A and compound B. So I wrote and balanced my equations, I framed it up, and then I used this frame up to help figure out this is A and that's B. Step 4. Is to use the diagram to determine which conversion factors are needed. Well, if I'm going from moles of compound A to moles of compound B, check this out. I just need the mole ratio. That's the only thing I need. So the next step is to write my conversion factors. The only one I need is mole ratio. The mole ratio of lithium to lithium oxide is 4 moles. Remember, it comes from the coefficients of lithium to 2 moles of lithium oxide, or I could write that as 2 moles of lithium oxide to 4 moles of lithium. And notice I am keeping full labels. Those are going to be helpful later on. Okay, step 6 is to insert your conversion factors. Insert your conversion factors. So I have moles of lithium on the top. That means that the next conversion factor to come, moles of lithium has to cancel. This one's not gonna work because moles of lithium is on the top. So this is the one that's going to work for us. I'm gonna put 2 moles of lithium oxide over 4 moles of lithium. It's multiplied. And now the rest of this should feel pretty familiar because we've done all of this before. We're going to cancel our units. Moles of lithium cancels, moles of lithium. And finally, let's see, what color haven't I used yet? We're going to multiply and divide. We've got 2 times 2 divided by 4, and that's going to give us 1 mole of lithium oxide. Now you might be thinking to yourself, oh my gosh, that was so much work for something that was really very simple. Well, yeah, we're just going here. What happens when we get out here? Things get a little bit messier, and we're going to go in steps. So we're going to kind of boil the frog by degrees here. But these apply no matter what we're doing. So at the bottom of your page, there is a practice problem, and I'm just going to slide my page here, where it gives you the disinfectant hydrogen peroxide decomposes to form water and oxygen gas. Go ahead and see how far you can get on this. If you need to pause the video, or definitely pause the video. If you can't get very far, that's okay. We'll work on it together. So, all right, go ahead, pause the video now, see what you can do. All right, welcome back. So we're going to go through these steps again. and I'm just going to kind of walk you through it. So we're going to write and balance the equation. The disinfectant hydrogen peroxide decomposes to form water and oxygen gas. So I have a decomposition reaction, H2O2. It's going to H2 plus O2. And it's already balanced. That's nice. So I've got whoops, hold on. Oh my gosh, I can't read. And I don't want to re-record this video. Forms water. Sometimes it can decompose into hydrogen gas. So I do need to balance this. All right, I've got 3 water over here, so I know I'm going to have to make this even. Let's do that. So I've got 4 hydrogen and I've got 4 oxygen. So if I put a 2 out here, I've got 1, 2, 3, 4, 1, 2, 3, 4, 4 and 4. 2, 2 and 1. Now I want to frame up my problem. How many moles of oxygen will result from the decomposition of 5 moles of hydrogen peroxide? So it gives me 5 moles of H2O2. I'm going to put that over 1, and I want to solve for, here's my question word, how many moles of O2? Now I want to label my compounds A and B. So in red, in green is H2O2. And in red, I'm going to put a letter B for stop for moles of O2. So I'm going from moles of this to moles of this. When I look on my diagram, just slide this back up. I'm going from moles to moles. All I need is the mole ratio. So that's the conversion factor I need. I'm going to write that conversion factor. I've got 2 moles of H2O2 to 1 mole of O2, or I can write 1 mole of O2 to 2 moles H2O2. It's going to have to go in like this when I insert it. Next step is to insert the conversion factors. Next steps to cancel my units. So moles of H2O2. And remember we said whatever's left up here should match what you framed up. So that framed up. So I cancel my units. That looks good. I multiply. 5 divided by 2 is going to be 2.5 moles. Okay, so that our takeaways here. We went through. We picked up the diagram that we got in the last problem. We talked about mole in the last video, and we talked about mole ratio, and we're using that now. We're using that to solve problems, and we're going to approach this systematically. So we're going to write and balance that equation, frame up the problem, just like we learned in dimensional analysis. This time, though, we're going to label compounds A and B. Use the diagram to determine which conversion factors are needed. Write those factors out, and then 6, 7, and 8. That's straight up review from doing dimensional analysis. Okay, that gets our stoichiometry party started. On to the next video.